Hello, and welcome. Today we have we code 2831. Find the longest equal subarray. So basically, you are given a list of numbers, and then you are also given a value k, right? So k is the utmost greatest number of elements that you can delete in a subarray or in in arms that like it's a possible operation that you can do that you can delete stuff. And um the goal of this problem is basically that you make at most k deletions and that you obtain a subarray. The longest one is what we want, right? The length of the longest one is what we want. And basically that subarray should have every single element in it to be, equal in value, right? So basically we have originally we have these nums, right? Have one, three, two, three, one, and three, right? You see, and you can see that one occurs twice, right? Two occurs once, and then also three occurs three times. So if we want our longest subarray, right, we can delete two as the answer says, and then delete one, right? And then you'll find that you have essentially this becomes your nums, right? And then this is the length, right, of the longest subarray, basically, where you have 333, basically. So, like, without further ado, I just want to take you guys through an example. I'm not going to be using the sliding window method, and I just want to explain it as best as possible. So I just want to use the example too. The k is small, and that's why um, I chose that one just for the demonstration. Right? So we have a nums of what size, not necessarily the size, right? But I have elements one, one, right? Then we have two, two, and then one, one. And note that we have what k is equal to two, right? So we can make at most two deletions per sub array, right? Now, what we can do to solve this problem is that we find for every single subarray, right? Like as we are sliding the window, basically, every subarray we want the element with the highest frequency, right? Because the highest frequency will help us to find basically it will help us find the number of deletions or the number of elements in there that can be deleted, right? So, for example, in this subarray, we say we have three elements, right? One is the element with the highest frequency in here, right? Because one occurs twice and two occurs just once, right? So I can use that now. If I had this subarray, how will I know the number of elements that I can delete, right? Well, I'll need the size of the subarray, and the size of the subarray is three, right? And how do we get that? We will have like two different pointers, right? We'll have like a left pointer, right? Let's say our left is here, and then essentially our right will be here, right? It is our right pointer. Now, to get the size of the subarrays is just what right minus left, right, plus one because of zero index, right? Left is not going to start one, and essentially also what right is not also at the correct place. So basically, it's going to be two minus zero plus one, and that will give you the size of the subarray. Now, to find the number of elements that we can delete, right? Well, basically, I can use the max frequency, right? So the max frequency so far is that of one, which is what two. So it's going to be what two. The whole thing is going to be what two, right? Our left is zero plus one, right? That's the sum array size minus what the max frequency that we have, and essentially, it's going to tell us that it is what it's going to tell us that we have one element that we can delete, which we can obviously see here, right? Two. We can delete two, and if we delete two, every element in the subarray will be what? Of the same value, basically, it will be equal. So we can use this formula to our advantage in our sliding window, right? When we open our window and then we keep, adding, we keep expanding our window as it goes, and then we check for the points where our right pointer minus the left pointer plus one, right, which is the subarray size minus the max frequency. Now, if this exceeds k, then we can move our left pointer basically. Right, we can move our left pointer as we go. So basically, we just need like a map, right, to keep the frequencies basically of elements, and then we can use this to our advantage. And funny enough, um, the results that we need is the greatest max frequency, right? Because max frequency is basically the occurrence of an element, right? The most times, and not just that. We are looking for the max frequencies, and we are going to make sure that they are within k, right? So the max frequency, whatever the size of the subarray is, right, minus that max frequency. So basically, the max frequency is the number of elements that are recurring, right? Like for example, in here we have one and one. So if this was the whole thing, then the max frequency I've seen so far is what, just two, and that would be the length of the longest equal subarray, basically, right? So basically, that's it. We need max frequency. Max frequency is the most helpful thing. Can use this formula. And I'll just take you guys to the coding as I can. Okay, so basically, we are back here, and I hope the demonstration was like very helpful. So basically, we need 2 pointers. We need the left pointer and also what's the right pointer, and then we also need a map, right? And if you come to our constraints, right, it says we have from 1, right, and the values are positive. So we have from 1 to 10 to the power 5, right? So I can make the size of this 10 to the power 5 plus 1, right? So 0, 0, 0, 1, right? This is the size, and then for every single value, I can keep account of its element. So basically, while our right so while our right is less than nums dot size, then we can do our iterations. And before that, I just want to declare this variable, basically, which is what the max frequency, right? So max frequency, I'll initially set it to 0. Okay, so in our while loop, I want to take the current element that we are dealing with, right? The one which the right pointer is on, which is what nums, I think, dot get right, because we are dealing with an array list here. So nums dot get right is given as the current value. For example, it will be 1 here, and as the window expands, so on and so forth. So we have it in our map, right? We keep account of its frequency. So we increase its frequency in here, and after that, basically, I want to check, right, is the frequency of map current, right? Sorry, is the frequency of current, is that greater than our max frequency? If it is, then set our max frequency to this value that was now once greater than it, right? So so our max frequency basically is going to be then other map current, right? If you're following. Okay, cool. Now, when do we move our right pointer? Well, basically, as I previously explained, right, we have I'll have a while loop for the violation, right? In the case where what's the right minus the left plus 1, which is the subarray size, minus our max frequency, right? Which is telling us the number of elements we need to delete. Now, if the number of elements we need to delete is greater than k, then we can move our left pointer, basically, right? And again, I want to have a grasp on what the left element is, right? Which is going to give me nums.get right, and nums.get left, and basically I'll decrease the count of that element as we close the window, right? Or move the left pointer in, right? So map, map left element minus minus, right? Whatever that is, and then I move the left pointer. So basically, this is how we close our window, right? We expand our window doing this. Just to culminate that, we have move the right pointer, and then here is where we do the work. So eventually, right, we'll have a max frequency, and our max frequency is essentially the number of right as the number of elements of a certain type or of a certain value that's allowable within k deletions, right? And that will be our answer, because that will double up as what our longest coming in the size of the longest equal subarray, basically, right? So basically return max frequency. um so that's the concept, basically sliding window problem. um and we passed the first two test cases, and I believe it'll pass everything else. So it should be fine, right? Within 94% of Java users. And what is the runtime of this? Well, basically, right, every element is going to be touched at most twice, right? So it is 2 of n, right, which is essentially O of n. So O of n time complexity, and the space complexity we just have. Basically, you have the map, and the map is going to be the map is fairly constant, but I'll say we have 10 to the power 5 elements in there, but like the constant map, you just make changes and stuff like that. If you use a hash map or something like that, then maybe that you can see then that the space complexity is what's O of n. Yeah, guys, I hope this video helps. Like the video. I need more subscribers, guys, and I'll see you guys on the next one. Peace.